All right. Hello, everyone, and welcome to NLP workshop. This is day three of our road to AiXData. And for everyone else that wants to follow along at home, in the Discord, there is a link to the GitHub right here. Follow along with the collab on the repo. If you go ahead and click on that, it's going to have everything that you need for the workshop. It's going to have the data set that we're going to be using for today. It's going to have the complete version with all the code inside of it in case you guys get lost along the way. And then also it's going to have our user version, which is what we're going to be working on today. And we're going to be working through it all. And also a README as well, like a little bit about the workshop. So again, like as everything we were saying, so what we're going to be learning how to pre-process and clean up raw text data. We're going to be learning different methods of categorizing these things, like using bag of words and TF-IDF. We're going to train classifiers using scikit-learn, make models, and then interpret their accuracy. So these are the tools we're going to be using. And then this is the data set. For all those that want to follow along at home, all you can either download the data set from Kaggle itself, which we're going to be clicking right here, which actually I already have up here. So this is the data set we're going to be using for today. It's IMDb data set. It has over 50,000 movie reviews. There's just two columns. It has the actual reviews themselves and then their unique IDs, which is like the sentiment. So whether they were negative reviews or positive reviews. So it's the most bare bone, like kind of simplest like data set like out there. And it's really good for NLP because it helps us it's pretty straightforward on like this like chunk of text means this positive. And then we can, label that along the way. If you want to download it through the repo, then all you have to do is just click on the data set, and then it's right here. And then you can just click on the CSV and then download that. So once you download it, or in my case, I'm going to download it from Kaggle. So, oh, there you go. IMDb data set. We're going to save it to my desktop just randomly. I'm going to open the file. Okay, now that I know it's here. We're going to go to my Google Drive because we're going to be using Google Colab for this workshop. I'm going to make a new folder. I'm going to call it IMDb underscore dataset. I'm just going to put data. There you go. Create that. And then now that I have it, we're going to go back to this. Ignore the mess on the desktop. We're going to go back to this. We're going to drag that CSV file into this folder. We're going to figure out why we're doing this in just a minute. So we're gonna let that upload. This is almost done. Um, Obviously, the larger the data set, the longer it takes for this. And once we have this, we're good to go. And we're gonna go back to the repo. We're gonna open up our new collab, which we're gonna be working. It's already gonna be already processed for you. All you have to do is click this open in collab button, and it leads you directly to here. So here we are. Here's the overall workshop we're going to go through today. Our overall goal is to get our model to predict whether our review is positive or negative using patterns and language. And we're going to be doing that using NLP, which is natural language processing. I'm going to be guiding you along the way, and I'm going to be guiding you along the steps as well. So, first step is to load and explore. After that, we're gonna our data set, we're gonna pre-process the text. We're gonna extract some features from the actual text. We're gonna train our models, evaluate it, interpret it, and predict it. And then we're gonna predict new ones as well. That's just the overall goal. So let's start by actually loading the data set. So and the most important libraries that we're gonna be actually using throughout this is gonna be pandas. So we're gonna import pandas as PD. This is just like it allows you to manipulate data frames, which is what we're going to be using for our data set to actually like manipulate. Next one is going to be import NumPy as NP. NumPy is the scientific like array like library. It's used in a lot of machine learning. It's like it's standard for like whenever you want to like modify a data set or if you want to like throw it into a model. In order to actually access the data set in a Google Colab, which I highly suggest using for the actual datathon itself as well, because it's very versatile. You don't have to download any libraries. Everything's pre-downloaded. It comes with its own storage. You can run everything on, and it's pretty good. But in order to access the data set, all you have to do is do from Google.colab, import drive, and then drive.mount. This is where you're calling the actual folder itself, and we're gonna go grab that folder. So you go over here, go to files. Actually, yeah, content slash drive. So this is gonna connect your Google Drive to this collab. So it's gonna be like this is not authorized. You run anyways. Okay, not two L's. Connect to Google Drive. There you go. And then continue, go all the way down, continue, wait for it to do the little check mark. That's how you know it's done. Cool, mounted. Great. So now we're going to go to files right here, and you would be able to access your Google Drive through Google Colab, which is pretty cool. So our next thing is we're going to pull that pathway that we just downloaded the CSV from. So right here, IMDb data. So, and there's the CSV file. So we click the three lines, click copy path. I'm gonna paste that right in there. And there you go. Now we have our CSV file and it's in a path that we can actually use. All right, our next step is to create a data frame. So you're gonna use pandas for this. Read CSV and then path. So now it's reading the raw CSV text data and it's turning it into a data frame. Next step is to visualize the data. We're going to be like actually showing these columns and rows. So we're going to do print f shape and then df dot shape, which is going to show its shape. And you'll see what I mean by that in just a minute. Df dot shape. And then we're going to show the first item of that and reviews and df dot shape columns. So this one shows the rows and this one shows the reviews or the columns. And obviously the rows is the reviews and the columns is the sentiments. So now we're gonna do print f count column names. My bad. And then df dot columns. This is gonna be converting it. Uh, Yeah, and then we're going to be showing the types as well of our data because it's important to just understand what we're working with, right? And then data types, and then df dot d types. The only reason I do D types is because when you convert it to a data frame, it's not just a normal data structure. You have to do D types, which just shows the exact same things. It's just extra, like, I guess, like phrasing for it. But and then df dot head, that just shows the first top five. Mm, let's copy that path again. There you go. It should be it shows like all the 50,000 reviews that are inside of it. It shows that there's two columns. And then it gives us the exact names of them and the D types and object. It's going to be showing these and then examples of these. So, like review, exact same thing we saw in Kaggle, but in this we're going to be doing it through our Google Colab. All right. Now for some pre-processing, we're going to be checking if there's any missing values, right? So, any missing values, all we have to do is df dot is null, and then if you do dot sum towards the end, it will like calculate all in total. Mm, if that is null. Oh, forgot the parentheses, my bad. There you go. And in this case, we have no missing values, which is great because that means this data set is completely filled out. That means we don't have to get rid of any missing values. Whenever we do plug it into a model, we don't have to worry about like conceptions or it like thinking that a missing value actually means something when it doesn't. So great, we can just move on. Next is the sentiment distribution. So this is going to be showing us like the like array of like the positives and the negative reviews. So we're going to be doing print and then df. Whoa, sorry. Df dot sentiment lowercase and then dot value counts. All right, cool. If you want to see what this does, it just shows how much of each is in each column or in each category. So the names count, the type is an integer. That's just telling you what it's showing right now. And yeah, you see there's 25,000 positive, 25,000 negative. That's good to know. It's even distribution. And then if we want to show the balance, we're going to be doing class balance. And then df dot, or sorry, not dot sentiment. Sentiment, same thing, value counts, which is going to show this like little graph right here. And then normalize equals to true. And then to dictionary, which is to dict. Just a function to create this as a dictionary. Normalize would be actually turning all these values into a scale from 0 to 1. So it's going to turn it into a percentage. And you can see that right now. Oh, no. Right. Yeah, I knew that. There you go. 50% positive, 50% negative. My bad, guys. A lot of typos today. Um, Anyways, we'll go on to the next one. So this is the actual visualization part. So there's two main imports that we have to do. There's from matplotlib dot pyplot as plt, and then import another one seaborn as SNS. This is where you get like a lot of heat maps and a lot of different other ones, but the majority, like industry standard, is Matplotlib. It's because you can get a lot of different graphs, like histographs, bar graphs, and all those other ones as well. Make sure to load those. Cool. Now that they're loaded, we're gonna be doing, we're gonna add another column because a lot of them are like crazy. So we're gonna try to clean it up a little bit, right? So, or no, sorry, not. We'll do that later. Right now, we're gonna be trying to see how long each review is because we're gonna see if there's a correlation in between like positive reviews and longer reviews. So, like, let's say we can try to find a pattern between the longer the review, the more positive it is, or most likely it's to be positive. So. In order to create a new column, all we need to do is just df, which calls that data frame that we've been doing, and then the name of the new column, which is review length, and then equal to df dot review. This is what's actually going to be inside of that new column. So we're going to be processing the review one, and then dot apply because we're applying a function to it. Lambda, if you guys have ever taken 342, you know about like lambda calculus and everything. So this is just basically applying whatever to every single review is x in this case. We're going to be applying the length of x dot splits. And basically what this does is it applies every review. It gets the length of it, and then x dot split. Basically, if it's a group of words, it will split it into different words, as I wrote here. So, like, let's say this is phrase saying "I love this song." It's gonna split it into "I love this song," and then Len will count this and be like four. So this review is 4 words long, and it's gonna be doing that and applying that to every one inside of review length. Okay, cool. Now that we have that, let's start plotting. So in order to plot anything, you have to create what's called subplots. So subplots have rows and columns of their own, and then or not columns, sorry. This is like each figure that you want. So if you want two figures, one figure inside of it, and you'll see what I mean more specifically when we write it. So in order to initialize that, all you have to do is fig, which is for figure, and then axes, which is each individual figure, and then plt dot subplot plots, my bad, 1, 3. So we're going to be doing one column per, and then 3 figures, and we're going to be doing fig size is equal to 16 by 4. Okay, and then in order to name it, you do subtitle data set overview. Okay, cool. Now let's run that real fast. Look at that. We created 3 figures. And then our title appeared on the top. Cool. Now we're going to be doing the sentiment distro. So this is where like we're going to be plotting like the positive versus negative feelings. So we're going to be first plotting our colors because I love myself some colors. And you can either do hex, you can do RGBA, you can do whatever you want, or you can literally just type green and blue. 'Cause I like those colors. Those are my favorite colors. And DF sentiments. And then we're going to be doing value counts, which it was that plot or that graph earlier. And then because we're trying to grab specific values from this. So I put that on the outside. There we go. And then dot plot. We're gonna be plotting those values. And so the kind like the kind of bar that or the kind of graph that we're gonna be doing is bar graph. So do it like that. AX, so this is the specific like axis or the specific figure that we're trying to do. Axis, and then we initialize, or not initialize, we grab the first one, which is 0. And then color is equal to colors because we like that. And then we close that. So this is one way to plot. You can just grab the specific column and then do value counts and plot those exact counts. Or we'll be just going over some other ways to plot as well. So now to customize these ones. So in order to customize each graph, you have to do set titles. So you have to tell which exact graph you want to like be changing. So in this case, 0 or index 0, and then set title, and then let's do sentiments. Sentiment balance. Okay, cool. Then for simplicity reasons, I'm just going to copy paste these because it's the exact same thing, except this time we're going to be doing X label to label the X axis, and we're going to be doing that as sentiment because that's going to be showing the positive and negatives. Let's copy paste that again, and then this time we're going to be doing the Y labels, and then this is going to be the counts. Okay, cool. And last but not least, there is these things called tick params. Tick params are basically just how you organize your X labeled ticks, or you can do the left side or the Y coordinates as well. But for our case, we're going to be changing up the X axis. So in order to be specific about that, axis is equal to X as X. And then rotation equals 0 because we do not want it to float or nothing. That should work. Let's try that out. Oh, look at that. Two bar graphs, one positive, one negative. If you just for fun, if you want to do like a 45-degree angle, you can. It's just going to be changing the X labels as well. So you can do whatever you want. When you have more cluttered data, people like to rotate them to the left or to the right so that they can actually see them and they're not all clustered together. But for our case, it's just two. So let's just run that. Okay, cool. Next thing that we're going to be doing, instead of looking at the sentiment, we're going to be looking at positive and negative reviews specifically, and we're going to be comparing them to the review lengths. So I'm gonna write one, and then we're going to just copy paste the next one because it's the same thing. So DF, and then DF sentiment, right? Because we're grabbing the sentiment. We're going to be creating a Boolean, and I'll explain why in just a minute. So in order to create a Boolean, you do double equal sign and then positive. And then outside of that, we're going to be comparing that to our review length. Review length, because we just created that right up here. And then, so this is one, and then this is the second one. And then because those are together, we can plot those. And then put that here. We do not want a bar graph this time. I want a histograph. So hist. And then ax, be specific about which one you want. So axes, let's do one because 0 is this one. And then bins, because it's a histograph, you have to label exactly how many bins you want. 50 is a pretty good amount. Our color, again, we don't have to be specific with any like hex or anything. Let's just do red. And then a label is equal to positive. Okay, cool. Hopefully you guys are following along. And that should be all the labeling that we need for that one. Now onto like actual customization, which is this part right here. So axis one, we're gonna set a title for it, and it's gonna be review lane. Um, Bistro. And then we're gonna be doing Instagram. My bad. Instagram. There you go. English is actually going to be the death of me. And for simplicity, we'll copy paste this. Instead of title, we're going to be doing X label and then word count. Because that's the X, no, the Y and the X. So X is going to be word count or the review length. And then paste it again. And then let's do Y label. Actually, because it's a histogram, we don't actually have to do a Y label, and we'll just do a legend. Okay, cool. And let's look at that. Uh, which is view length. Let's just, to be specific, grab the exact. Oh, I never, I never wrote it. Yeah, that makes sense. Oh, and now there's nothing there. Wow. Okay. Let's do this again, but let's copy paste the whole thing in here. Yeah, that makes sense. See, I can code, but I cannot have common sense sometimes, I swear. So yeah, this is how it looks. It's gonna be like a histogram, and each bin is these are 50 bins in here. So if you want to be more extended, you can do like 100. very small bins, or you can literally do like five, and they'll be very big. So 50 is a good even distribution. You can see like the graph as if it was like a normal like parabola or a normal line. So this is pretty good. And then we're gonna be doing the same thing, but for a negative. Um, yeah, for a negative sentiment. So let's do that over here. Except we're going to be doing it on the exact same distribution or on the exact same axis. We're going to be doing, let's just put that since it's down there. Let's do negative. And then after the negative, we'll change this one as well. Negative. And then we don't want it to be red because that's going to be conflicting. So let's do blue. And voila. Now there you can see the clear difference between the amount of words used is more in the positive compared to the negative. All right, cool. And now we're gonna create a box plot to show. Sometimes box plots are pretty useful when you're comparing to like two things, two classes. So in this case, positive versus negative. It's pretty useful. And we were trying to compare those two sentiments with the length of the reviews. So you do box or df dot box plot and then column and then review length, right? And then so this is what you'd be going by, and so you'd be going by a sentiment. So X, Y, and then it would just pull the sentiment from DF. You don't have to do exactly like uh DF this, because it is already pulling from here. So by sentiments, and then X, you have to be specific about which one. Let's do it on the last one. So two, index two. Okay, cool. Now we have to be customization. So ax2 dot set title is review length, right? And then by sentiment, and then let's do copy paste because it gets repetitive after a while. And then label. Okay, cool. Boom. Y label. We only have to not do a Y label on the histogram, but everything else we still have to do it. And then review. Okay, cool. Now, in order to actually show everything, this is just like plotting, like Matplotlib is just guessing on what the like estimates you want to be. So in order to be specific about it, you have to do matplotlib.show and boom. But you see how like everything's kind of like grouped together and like it's not really like evenly distributed. So in order to fix that, you just do plt.tight layout. And then you run that and boom. They're evenly distributed from each other. So it's a pretty good technique, a little thing to like make everything organized. This is the box plots that obviously show significant outliers over here for the positive, and everything's kind of grouped together for the negative on the lower end. So it's good insights to have. Now let's actually look at the reviews about what we're actually going to be, you know, like deciphering and like putting into our model. So let's do a simple for loop for review in df dot, not dot, dash, df, and then you grab sentiments. Again, we're going to be doing a Boolean. So if it's positive, right, we're going to be grabbing the review for it, and then we're going to be grabbing two random ones. So for pandas data frames, dot sample is pretty is the one that you would want to do to grab a random one from that column, right? So because it's a for loop, we're going to be going through it. We're going to be printing every single, or just two random ones, right? So we'll be doing this, and then boom, sorry, boom, boom, and then let's do the review in there, and then just the print underneath, just to have some spacing. Run that. Okay, cool. So this is an example review that we're going to be going over. For all losers who gave it a negative review, it's because you probably just had yeah, but it's like it has a lot of words, a lot of like grouped up things, a lot of things that are not um I guess like you can't really tell if it's positive or negative like just from like those things. And then one yeah, but this is basically how it's gonna go. Like we don't need these things. A is irrelevant for us, so we'll be getting rid of those. Let's see if I can do a different one. There you go. There's also HTML tags inside of these reviews. That's just because like sometimes when you pull raw data sets, they get like corrupted like that. So we're gonna have to categorize those out. And then all the rest of them, we're just gonna do some normal pre-processing in order to grab like our like words that we want to focus on, basically, to try to train the models. So that would include getting rid of any lower cases, removing punctuation. We're gonna tokenize the actual like reviews. We're gonna remove any stop words, and then we're gonna lemanticize, right? We need to normalize everything and clean the data, the text before feeding it into the ML model. So normalize just means again turning any like array into like or integer array into a percentage. So it becomes a decimal or one or zero. And then the tool that we're going to be using for NLP specifically is import NLTK. So what that means stands for is Natural Language Toolkit. This has gonna have all the libraries and all the different tools that you need to actually manipulate the text. So it's gonna have our tokenization library, our normalizing words, everything else that we need. So we import that, and then I already have these kind of pre-downloaded for you because it is a lot. I'm just going to explain what everyone has. So for NLTK, it's really useful, but it has its limitations. SPA is better for like larger data sets for more processing things. But as far as like from small to medium size, this is like 50,000 would be considered medium. I think over 100,000 is considered like larger. So we have stop words from here from corpus. So basically any stop word or what a stop word is like things like the or is or a. It's basically not important. It doesn't tell us any significance whether they think it's like or a positive or a negative review. Tokenize. So tokenization is basically again grabbing like a full string and taking them into specific parts. So it'd be turning this one string into two strings inside of a list, and then we can count that and say there's two words. A lemanticizer. So what lemanticizer is it's basically a tool that allows us to go from like an adjective kind of or like anything that's excessive to its base like form. So it reduces the amount of letters we need to count and reduces the amount of like strings we need to look at. So an example would be going from like running to run. And then after you like call the libraries for these things, you do need to download them. So again, it is like a tool set. So you do need to download all the tools in order to actually start using them. So we're going to be downloading Punk T. Quiet equals true. It just means that it's not going to like show in your terminal that like it's downloading. If you don't have that enabled, it's going to show like, oh, downloading now, which is just preference. But yeah, so we got all of that ready to go. And then Re is just a normal, it's a pretty popular library just to do text manipulation within like in general, not just for like natural language processing for like machine learning, but just in general, if you wanted to like manipulate text, Re is the normal one to do. All right, cool. So now we're going to be moving on. We're going to be first using the getting any stop words and then initializing our lemanticizer. So stop words, we're gonna put that there, is equal to set. Set is just converts it into a Python list because it doesn't come naturally as a Python list. Stop words altogether dot words, and then we're gonna be initializing it to English because I believe you can use any language, or it has its limitations, but you can look in its like documentation to see which ones are accessible to that. Next one is we're going to be doing lematizer equals word net lematizer, and again we initialize that up here, and then parentheses. Okay, cool. Now we're going to go on to our function that is going to do the pre-processing for us. So first step is obviously to do any conditional. So see if it's actually empty or not. So if PD dot is an a text, and then return an empty string because there's nothing inside of it. So is NA is a pretty good command to know if you're going to be using pandas in general. This would return a Boolean to see if it's true or not. So if it has no values inside of it, it's going to return true. If it has values inside of it, it's going to return false. So if true, return nothing. Next one we're going to be going to is we're going to be going on to the text manipulation part. So we're first going to be importing re. So we're going to be doing text because we're still using the same text and returning the same text, just manipulated. Re dot sub. So sub just stands for substitute. So we're going to first put what we want to take out and what we're going to replace it with. So for any re function that you do, you have to initialize it with R and then single quote. This one's kind of, so we're going to be getting rid of any HTML tags, right? So the HTML tags obviously start like this and end like this. On the inside, we're going to be putting dot and then asterisk and then question mark. Okay, and then we're going to be replacing anything within there with nothing to say that we're deleting it. And then we're going to be grabbing that from text. So the period it just means like match any character with anything similar. So in this case, we're going to be matching any character that's in this position after a opening tag. And then the star means repeat any process until it's the other one's found or until a condition is met. So this is the condition. It's going to be repeating what the period is doing, and it's going to be like finding any character within its position. It's very important to have the question mark as well. It's basically a lazy evaluation function. So it's saying stop at the next one, the immediate next one. If you forget that, then it's going to keep going and it's going to keep grabbing until it finds another tag like this. But once you have that, it stops immediately after finding the next one. So that's just a little bit about re. Next step is to make everything lowercase. So that one's pretty easy. Text dot lower. If you were like in your first 174 class or like your first intro to programming class, I think we learned that. Next step is to keep any letters and spaces. So we're going to be getting rid of specific things. So I'm going to just type it for you to see first. Text is equal to read dot substitute R and then single string. We're going to be doing a bracket to like say that this is a group of things that we want to skip over. And in order to actually initialize that we want to skip over it, we do an up like hat. So it says match anything not in this list. And then we're going to be doing A through Z. That's just saying like any like lowercase. Um, and then we're going to be getting rid of all the white space as well. So that in order white space and re is the backslash and then S. Okay, cool. And then we're going to be, in order to get rid of it, like that. And then we're going to be pulling it from text. Okay, cool. Next step is to tokenize. So like we were saying before, we actually have a function for that. So it's we're going to be creating a new variable called tokens, and we're tokenize, and then we're going to be putting text in there. Um, Now the next step is to remove any stop words, so anything like it or anything like that. And we're gonna want to remove like any irrelevant like words that are not don't mean anything, and aren't gonna help us in our like actual model. So we're gonna be throwing a for loop for that because we're gonna be going through all the tokens and checking if it's a stop word or not. So T for T in tokens, if T not in stop words, and len T is greater than 2, then we'll be putting it in this list right here. So if initialize a variable, and then for T in tokens, so for every single token, if T is not in the stop word and it's greater than 2, so it's not like it or anything else, we'll put it in this list right here. And then that's getting rid of any stop words or any like unimportant words, really. Last one, we're going to be lemmaticizing it, so getting rid of or putting it in its base form. So tokens, pulling the same list that we got last time, lemmatizer, and then dot lemmatize is how you use the lemmatizer. And then we're going to putting T in there for T in tokens. Same thing with the for loop, just checking every single one and putting it in its base form. So cool. Got that. And then the last step is now that because it's a list, we want to make it a string again. So we're going to be returning, and we do that with dot join. So return space in between each value and then join. And then text. Okay, cool, guys. Now that we have that, let's run that and see how that goes. Boom. And it's all good. Okay, cool. We'll move on to the next step. So we're gonna show you how it worked exactly. So we're gonna be pulling a raw like data like before we cleaned it with df.review, and then iloc is just it's called integer location, so it's basically just like pointing to the index that you want inside of a data frame. So in this case we want 0. And then we're gonna be doing raw clean. We're gonna be cleaning it up. Reprocess text, and then raw. And then after that, we're going to be printing both of them so you can see. So we'll be printing the raw and then the clean raw, or raw clean, my bad. And then we don't want the reviews to be that long, so we're just going to be doing 400 like characters, and then we'll stop. Okay, cool. And then let's just run that. Okay, cool. I think I put too much space. I know. Oh, my bad, you guys. So we're gonna be doing the tokens, not text. Yeah, because that tokens is actually the list. And then so we're gonna do that again, except with the space this time. Cool. So obviously everything is lowercase now. Some words have been like removed, one of the other, and then one reviewer. It This is a example of like the lemanticizer, going from reviewers to reviewer. Mentioned watching an episode, and there's no As you can see, there was like some HTML tags over here, no longer there now. And it's basically proof that that it works. So now we're going to be creating a column just for these new clean reviews. So df dot clean reviews, and then we're going to be putting that into each review. So we're going to be grabbing the reviews, right? And then we're going to be doing the same thing we did last time because we're applying a function, and this function is our own made function, preprocess text. Okay, cool. Now that we run that, um, oh, reviews. It's gonna take a minute because, it's just going through every single review and actually doing the pre-processing. So while we wait, we can just write the verified that it worked. And in order to verify it, we just look at the data frame. So all we got to do is just df, um, and then we're gonna be calling each category inside of it. So review, and then we're gonna be doing clean reviews. And then sentiment, and then dot head. And then dot head basically just returns the top, I think by default 10 categories of a data set or of a data frame. But if you want to be specific, you can put a number in there. So we're going to be returning the top five. So once this is actually completed, then we can go ahead and verify if it worked. And then we can move on to the next part, which is going to be on word clouds, which is pretty important if you want to know like which words pop up the most. And that will be more important as well later on when we're actually creating our feature extractions for the model itself. So in the meantime, we'll just wait for this to actually execute. Do. Still executing. There you go. Okay, cool. It did it all. And then we'll just verify it worked. And look at that. You can even tell just straight from like this little bits that it went from this to HTML tags to working. And it has the sentiments. Very cool. Next thing we're going to be going over is word clouds, which is it's just another graph that you guys can use to actually look at the words and your actual like sentiments, or no, within the reviews itself to see like which ones pop up the most. And in order to do that, we just need to import word cloud. So word from word cloud, import word cloud. Just run that. There you go. Now we're gonna start off by doing the positive, by doing the two different categories, right? Which is of the sentiments, which is positive and negative. So let's start with the positive text, and then we'll be doing a dot join to put the list together. And yeah, we're gonna be grabbing sentiments. We're going to be creating a data frame, but inside of that data frame, we're going to be using these specific categories. Is equal to positive. And then after that, we're going to be having its own clean reviews. Okay, cool. So it's saying inside of this data frame, only grab the clean reviews that are positive. So I know there's no like if statements or anything, but it actually works. And then after you grab that data frame, you're going to be putting it together into a single string. So this is just like a thing. This is like a string of only the positive reviews. We're going to be doing the same thing, but for negative reviews. So honestly, just copy paste it, neg text, and then negative. Okay, cool. And then it's also pulling from the clean reviews. Now we're going to be actually plotting, right? So again, in order to plot, just fig and then axis, which tells you exactly how many figures of each. And then you do PLT dot subplots, one, and then for our case, we only want two because positive and negative. And then fig size is just the actual size that you want of your figure. So for this case, it's goes by inches, so it will be like 16 inches by 4 inches of the actual thing. Okay, cool. Now we're gonna actually create our word cloud. So in order to create a word cloud, all you need to do is do word cloud, and then you initialize its width, which is 700, and then its height being 400. Okay, cool. And then color map. This is like each word on the word map. What color do you want it to be? You have to give it a generals, and then it will like, space out like I guess like the variety of that color. So for our case, we're gonna put greens because I like that. I like greens. And then max words. If you have too many words on the word map, it's gonna be too cluttered and you won't be able to analyze anything. So let's just do 80 and then dot generate. And then you use the positive text, which is just all the words that we have that from the positive reviews, and then to image, which just creates it into an actual like an image that we can actually use, like the file converter. And then after that, which should run, right? Color map. And it should be going through it. And then while that's going through, we're going to be showing off the first plot. We're gonna do I'm show. So now that it's an image, it's just gonna be calculated as an image. Now we need to show it. So you initialize the first figure to show it. And in order to do that, you just initialize the word count again, uh, up to the generate part. Yes, up to the generate part. So put that in there. Yep. And then after that, there's this thing called interpolation. So interpolation is just what like the smoothness of it, of how they go around. So this is it just raw, like without it. And this is like an example of how it would look if you want it actually on the plot. We're gonna be like initializing it right now. So interpolation is equal to bilinear. Okay, cool. And then axis, and then we're going to be going to set like customization for everything. So set title and then positive reviews words. Okay, cool. And then doing the same thing, but for we're going to be setting the axis off. And then we're going to be doing the exact same thing, but for the next plot. So we'll just copy paste this. Okay, cool. Moving on to the next one. So, and then replacing it with the first one. And then mm, mm, negative, and then neg. Okay, cool. Cool, cool, cool. And obviously we don't want the same colors, right? So we'll just do reds. You have to add the S so that it has like the variety in it. And then once you run that, oh, you do plt.show as well. It will do it by default, but it's better to have it initialized so that you're not keeping Matplotlib guessing. Mm, 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 mm. And then mm, 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 mm. Okay, cool. Now that that's still loading. It should be another couple of seconds. I can just talk about the next section, which is going to be about feature extraction. So this is where we're actually going to be converting the words and the text into a numeric matrix, and then after that, we can actually convert those through normalization into percentages, and then calculate those probabilities for our model. So there's two methods to doing this. There is the vectorizer, which is where every unique word becomes a column in itself and it counts how many times that word pops up. Or there's TF-IDF. TF stands for term frequency. IDF stands for inverse document frequency. So basically it's saying how many times does this word appear and how rare is this word across like all the reviews. So an example would be like film appeals everywhere, so it has a high IDF versus like masterpiece. It only appears in like one or two reviews, then it's very rare and it has a low IDF. But yeah, going back to the word maps, this is how they look. So positive reviews, you can see that film, one, movie, people, story, love is a little bigger than everything else. Funny doesn't pop up that much, I guess, but the rest of them. But for the negative reviews, you can see like little, one, um, bad, kid, another, like just these other ones. We're gonna actually pull meaning out of these words in a bit, with these coming up right here. So these are all the necessary libraries that we need to actually go onto feature extraction. So I already like kind of gave these to you guys, so that way it's like it saves us time when it comes to actually building these things. But again, I'm just gonna talk about them. So from scikit-learn is where you actually pull all these things from. Feature extraction dot text, and then count vectorizer and TIDF vectorizer is basically these two methods. We're also going to be making our logistic regression model, a multinomial NB model, a linear SVC, which is a support vector classifier, and I'll explain more about what these mean later on. We're going to be pulling from model selection, train test split, which is to actually train the model on the X and Y data. We're going to be pulling some metrics, like a classification report, a confusion matrix, an accuracy store, and like all these other different things to actually see how like accurate everything is. We're going to be pulling pipelines to make sure that each model itself has specific parameters, so specific like classifiers and also um, other features as well. And then make classification, we'll be learning that about that stuff later. So just download this stuff. Moving on to the next one. We're going to be showing an example of like how vectorization works exactly. So we're going to be initializing the vectorizer, right? So CV demos and then that counts, no vectorizer, and then these two things. Um, yeah, and then we're going to be creating a matrix. And then CV demos dot fit transform, and then mini docs, which is these reviews. Okay, cool. So we initialize the vectorizer, and then using that vectorizer, we're going to be doing fit transform. It comes and just learns the word, and then it converts it into a numeric matrix. So we're going to be creating a pandas data frame to actually look at that matrix. So we're going to do example data frame and then pd dot data frame and then matrix dot to array, and then this would be turning the matrix into readable array. Pretty self-explanatory, honestly. And then columns is equal to sorry, CV demos dot get featured names out. and then these things. Basically what this does is it just pulls all the vocabulary out of CV demos and then sorry, it pulls them from the column names into a list. So yeah, so it's actually, readable to the data frame. Pulls vocab, and I'll put it here so you guys remember from column names into list. Okay, cool. Last part is going to be index is equal to review one. And then we're just gonna copy paste these because it's just all the reviews. Three, this one's two. Okay, cool. And then we're gonna show it off. So print XDF. So as you can see right here, each review it goes from oh, this is just going background. So acting it only appears once inside of review three, and it'll make a column and then shows how many times it appears. Great appears twice inside of review three, and it's just an example of how um this vectorizer actually works on like a piece of text. So this next topic I want to talk about is called n-grams. So using this vectorizer, instead of it making a unique column per word in the text, in the like text, it's going to be grouping things. So instead of it just being not good, it's going to be not good, which not is a negative connotation, good is a positive connotation. So obviously, those two words, when you put them in unique columns, are going to be showing up as negative and positive. But when you group like words together as a one feature, it's going to be not good together is a negative connotation, which is most of the time how human language is, right? Whenever we say something is not good, we don't mean it's like negative and then positive. When we say it's not good, it's just not good. It's negative entirely. So this is why it's, pretty important. And I'm going to be showing you how to do that right now. So it's called a unigram when you do a single column or a unique column per word. And let's create that right now. So CV unigram and then vectorizer and then ngram range is how you call it. And then it's just parentheses or it's a tuple. So it's one word per unique column. And then we're gonna be doing a data frame for these. So PD dot data frame. Well, let's do this. And then let's do that right there. CV unigram dot fit transform, which is what we went over earlier. Transform negation examples, which is these diction or these list up here. And then to array, which is how we actually feed it to the data frame because we cannot feed it a list. It has to be an array. So columns, CV unigram, and then get feature names out, my bad. Again, which is just pulling um, each column for data. And then index is equal to negation examples. Okay, cool. And then we're going to be showing the difference between that one and bigram, which is what I was talking about earlier, where you group like certain phrases and features together. And we're going to be just doing the exact same thing, except making it a bigram. And the only difference between that and this is that you change the amount of words that you group together. So two is the maximum that it can group. Doesn't mean it's going to group every two words together. It means it's going to group two words that pop up most commonly together. So, and then bigram, and then fit transform to array. and then bigram, get the feature names out, the negation examples, and then we can run that. Then as you can see, without the bigrams, and it's just pulling one unique, it's just saying bad, film, good, not. So that's like two like negatives and like one positive, one like whatever, right? But if you put them together, you're gonna be having not bad film and then not good film, which is like, two completely different like meanings. And then it's going to show that it's like popping up as not bad film more, which is the actual truth, because uh it's going to have like a negative connotation to it. Then we can use that later on. Okay, cool. Now we're going to actually be training our models. So we're going to be using binary classification. So for every like positive review can be a truth or a false, and then based off that true or false, we're going to be converting that into integers of 0 or 1. So DF, this is like a pretty common way to actually do classification for like supervised learning as well, because you do have categories and you do have to make those into numerical values. So our specific category is label, which is where like is our new column that we're going to be creating, sorry. And then we're going to be pulling from DF sentiment, but we only want the positive ones. So you do the if, and then as on the top, as type is a type converter and an integer. So again, what this is going to do is it's going to pull a Boolean if it's positive or not. And then if it's positive, it's going to be true, which is going to be interpreted as 1. If it's negative, it's going to be false and then 0. Okay, cool. Now we're going to create our X and Y's, which have you ever done machine learning before? It's just the data input that we're going to be feeding the model itself. So the columns, so it's going to be df.cleanReviews because that's what we're actually going to be giving it. Okay, cool. And then the Y is going to be our labels, which is positive or negative. Okay, cool. And then last step is to do the actual test and train. So train is what the actual model is going to be like running its loops on. It's going to be actually feeding into it. Test is the actual correct models that we're going to be, or the correct labeling that we're going to be comparing it to for accuracy purposes. So X train, X test, Y train, Y test. Okay, cool. And then you do train, test, split. X and then Y, and then test size 0.2, and then random state is equal to 42, and then stratify is equal to Y. Okay, cool. So random state is just like how many random samples you want to do. The test size is just like how I guess like how like accurate it would be, and then not accurate, sorry. The test size is just like it's not relevant for right now. Stratify, damn, I forgot what Stratify does. I know it though, but yeah, I think Stratify just oh, it's where to actually put your predicted like models. Sorry about that. Or no, sorry, predictions. To do where to put the predictions. My bad. And then training samples is going to be over here. We're going to be doing len of x train and then x test. Okay, cool. Which you can even just see right now, which is not sentiments. Oh, I see. Yeah. I put this labeling over here wrong. There you go. So it's gonna be showing you how many like training samples we're pulling and then how many testing. So how many we actually have. And then it's just pulling a couple like random ones. So in order to show the results, we're gonna do print and then F code and then PD dot series, right? And then positive. And then we're gonna be showing those as Y train. And then dot sum just adds them all up together. So we actually have one numerical like sum that we're looking at. And then we'll be doing negative is equal to, oh, it's a dictionary. So we have to put a key and a value. And then train goes to 0. And then dot sum that. Um, and then you can see how many positive reviews and how many negative reviews we have, which is an even split of 2020 and 1,000. And then it shows the type, so it's the integer. But yeah, that's actually training the model right here with our X and Y's, which is the clean value after pre-processing and labeling, or not labeling, just pre-processing, and then the labels of which ones we want. Now we're actually going to train them with the different types. And in order to do that, we're going to be learning pipelines. So instead of initializing a vectorizer and a classifier per like model, like specifically, we can just call it from the pipelines. And then that way we don't have to call it every single time. And it just saves us more time in general. So we're going to be pipelining naive Bayes, logistic regression, and then linear SVM. So this is an example, like inside this pipeline is like all these different things for each model itself. And then dot fit, it just makes it easier because you can just run dot fit on that pipeline and it'll run through everything. And then it runs both the vectorizer and the classifier. And then predict calls the vectorizer and then classifies all the percentages. And then it will use those percentages to make its prediction. So in order to actually call a pipeline, we have to do from sklearn dot pipeline import pipeline. Okay, cool. And then now that that's imported, I kind of want to go over what a naive Bayes is. So a naive Bayes is a classifier that turns your numbers into predictions, as I told before. But the way it works is that the more often that that word pops up, the more the higher percentage it's going to get on in the naive Bayes algorithm specifically. So like an example is like hello pops up twice. So like hello's gonna have 50%. Meanwhile, like wow only pops up like once. And then like it's considered rare, so it's like can have like a 10%. And the same thing with this word, it's like a 10%. So it learns probability just by counting how many words pop up. And then based off that probability, it's gonna predict which one it is. So in order to create the pipeline, we're first going to create the Naves Bay. So we're going to call it that, Naves Bay. And then it's just like, this is just this nickname. And then pipeline. And then that's going to be considered that. And then because we have to put a list inside of the actual pipeline, because there's multiple different containers we need. So vectorizer. And then now vectorizer, which is how you actually use the vectorizer. And then we're going to have its max features be 15,000. So 15,000 words this would be referring to. There you go. Three zeros. And then after that, because it's a list, we move on to the next one. and that's going to be considered the classifier. So this is what's actually calculating the percentages. For that, we're going to be using a multinomial NB, and then alpha is equal to 1. Okay, cool. This is the part that's actually like classifying each percentage. Um, and yeah, so once that runs through it, it will actually like calculate the percentages and it will return your list of words into percentages that it can do. And then we're going to be doing the exact same thing and creating a pipeline, but for logistic regression. But because it's basically the same process, I can just copy and paste it and replace the actual labeling. So logistic regression, and then uh, TF, That's the classifier we're going to be using. Pipeline, and then vectorizer, because every single model has its own, um, got a comma here. It has its own vectorizer and its own classifier. So in this case, we're not going to be using the count vectorizer. We're going to be using the TFIDF vectorizer, and then keeping its max features at 15,000. But this one, we can use n-grams, which we explained the importance of before. So in order to do that, n-grams range, and then again, you bring a tuple into it. So it's 1, 2 for a bigram. And then after that, the classifier is going to be different as well. We're going to be using, for this linear regression model, linear SBC, which doesn't have an alpha in it, but it has rather a C is equal to 1, which is just like um C is just a regularization strength. So it's like the overall over like it just tells you how much like overfit to do. So if it's too much data, like what to do with it. And if it's 1, then what's it called? It's gonna be like kind of a base model for it. And then we're gonna be going over max iterations. Let's do that at 3,000. Okay, cool. And then for the last step, we're going to be doing the exact same thing, making another pipeline, but we're going to be doing it for not linear regression, but linear SVM. And then again, we're going to be using the TF IDF uh, classifier as well. Oh, sorry, vectorizer. And then same vectorizer and same n-grams range, but the only difference is going to be I mix these up. My bad. So linear SVC is what we're going to be using for the SVM. And then logistic regression is what we're going to be using for obviously the logistic regression. And then, yeah, everything should work properly. I'm just going to run a real quick test on that. Okay, I forgot something somewhere. Hold on. Do this. No. And comma. I think that's it. Max feature. Oh, eh, it's max features. Yeah, with the S. And also ngram, not ngrams. There you go. So that runs properly. That means that all the pipelines are connected, and you can now just call pipelines and then be specific on which one you want. So now you can go into, we're going to actually save all the results into a single dictionary that we can call. So results into an empty dictionary. Okay, cool. And then for name and then pipeline in pipeline dot items, which is because it's a dictionary. And then we're going to be doing print f training and then saying exactly which model we're training and then name like that. Okay, cool. And then pipeline dot fit and then X train because we're going to be training on these specific models now. And then Y train. Okay, cool. Then we're going to be saving our predictions in here. Right equals pipeline dot predict, which is that simple call that I said before. And then predicting X test. Okay, cool. And then accuracy, we're going to be saving that in the accuracy score. This isn't a function that I made, but we called it within the libraries that we imported up here through accuracy score through Scikit learns metrics. Okay, cool. Oh, too far. Accuracy score and then Y test. And then we're also going to be doing Y pred. So we're going to be comparing the actual results to our predicted results. And then results, name. We're going to be saving each specific like variable in for every single like model, like its own data. So creating a dictionary for that. So pipeline, which specific pipeline it is, which it's already being specific in the for loop. And then Y pred, which is the prediction. And then accuracy, which is just the accuracy. Okay, cool. Now that those all saved. Oh, no, 2-1. Oh, it should be running properly now. And you can see that it's working right down here. Like first starting off the naives base, and it's going to be doing the vectorizer for that and its own classifier for that. Ooh, right. And then obviously moving on. And then once it does the last one, then we can move on to the next step. I wanted to kind of be clear on like the difference between a regression and the like regression model and the SVM model. So obviously a linear regression is just trying to find the best fit based off linear like prediction. So it has a like simple Y, like as long as X increases, Y is going to increase. But SVM would be trying to find a best fit line that differentiates two groups. So this is like an example. This is not related to the actual model we're working on. This is just a visual, so that way we can see the actual difference between the two. So we can look at that while this is waiting to load, and then based off which one loads first, so we can look. Mm, mm, All right, now it's moving on to the last one. It takes a minute for everything to work, and it's not gonna happen just right away. So right away. And then we are almost done here. So got a couple more sections to try. Okay, cool. Both finished. So now these are all trained, and then also we can show an example of a clear example of like regression just being the best fit line to fit like the slope, and then linear is SVM trying to differentiate the two different groups as well. Okay, cool. Now that we've trained our models, we can actually create some reports to verify its accuracy. So in order to do that, we're going to be going to making a quick for loop uh, for each name and then result in results dot items because we just saved all of them. And then name and then we're going to print what's called a classification report, which is going to go over all of these different metrics. So it's going to be doing the precision, the recall, F1 score, and then we're going to be making a confusion matrix in just a bit. And then not that, you need this, just normal parentheses, Y test, which is actual true labels. And then we're going to be doing results. And then Y predicted, which is what the model predicted. And then we're going to be doing target names, which is the labels that we want. So it's negative, and then also there's positive. Very cool. And then we're going to run that real fast. As you can see, it shows the scores that they got for them each model. So for negatives, 84%, like this is all accuracy. And then support, it just means how many like samples it's actually taking this from. So 5,000 samples per, which is pretty cool. And it says it for each model. And then the confusion matrix is just a way to visualize what's like what we actually predicted. So we do a fig and then axis is and PLT dot subplots, which is what we've been doing for the past couple of figures. And then fig size is equal to 16 and then 4, or to 18 and 5 be different. And then give it a title real fast. Fusion matrices. And then it's like predicted versus actual. Okay, cool. And then yeah, we're just gonna be creating the confusion matrix now. So for X and then name result in zip. Zip just allows you to iterate through multiple lists at the same time. So we're gonna be going through each figure, and then each figure per list of figures, and then results dot item. It's gonna be grabbing each item from the dictionary, which is its name, and then the results. Then we're gonna be making the actual confusion matrix, which has the actual results, and then which is the results, and then ypred, and then display equals confusion matrix display. And then that's just the function to actually display it, to actually show it. Pretty self-explanatory. And then matrix is equal to CM, which is what we called ours. And then display labels. and then the labels that we want. So negative, and then positive. Okay, cool. And then in order to actually look at that, display, uh, uh, and then make sure the axis is like specific to each one. And then clear bar, and then CMAP is equal to blues, which is the same thing as like the for the word the word cloud, just the labeling. And then moving on to the next part, we just do some customization. So dot set title, and then so this next part is going to be displaying the accuracy scores. In order to do that, we just have to name dot split, and then look for like anything that has the parentheses, which is in each model itself. Um, yeah, it's in each model. So we're gonna be looking for those parentheses, then grabbing the first one, and then dot strip. And then after that, getting a new line, and then res accuracy. Okay, cool. And then we're gonna just plot it. So EOT dot show. And then we do the tight layout in order so that the words don't over cross each other. Okay, cool. And now we can see uh the like accuracy and then for each predicted model. And then let's say that we want to compare each model to choose which one we want. Um I'm gonna be grabbing a list of names uh from the dictionary, right? And then we're gonna be doing fig and then ax to create a PLT subplot. And then fig size, because we don't need to do the 1, 2, because we're not creating more than one. So just initialize the fig size, which is just equal to 16 inches and 4 inches. So width and height. And then bars, because we're going to create a bar graph to try to compare everything, is equal to AX dot bar H, which is another way to create a bar graph. And then you pull the names as the y-axis, and then accuracy score is the um, x-axis. And then color, because there's 3 different models, we have to give 3 colors. So red, green, and then blue. And then you can initialize the height as well. Okay, cool. And then set X label, do like accuracy, and then X dot set title to model comparison. And then you have to iterate through each accuracy score to like accurately predict on the x-axis. So you have to just do a for loop for that. So for each bar and then accuracy, and then go through the list of the bars and the accuracy scores. And then ax.text bar get width, and then or dot get y. Okay, cool. And then you just gotta go to the next one and display each accuracy score. So, and then yeah, if you guys remember like how to place decimals correctly, the .2f is just after the second decimal. And then VA is just a vertical alignment and then in the center. And then you actually plot it. So PLT dot show and then PLT dot type layout. Cool. Uh, subplots. And then X. And then this should be working. Hold on. X is not defined. Mm, the previous one should have ran. So accuracy should be defined. Oh wait, no they're not. I'm so sorry. I completely skipped over that. X is not even a thing. And then yeah, so we have to actually create a list of all the accuracy scores. So you do because we're going to be like iterating through each of the results, the values of the results in the dictionary. So we do R and then to stand for like the results accuracy and then times that by 100 because it comes as a decimal and then for R in results dot values. There you go. Yeah, there you go. There. There you go. Yeah, and then it's going to show each model specific and then the accuracy score for each, which as we can see right here, the best model is the Nave's bow or Nave's base, which is interesting because last time I tested it was the linear SVM. So it's pretty cool to look at. Yeah, and then yeah, so and then we can skip over this. This is just like to show each top words for the regression model. But I do have like everything here so I can show how it works. Oh, wrong one. So it's going to be pulling the specific pipeline of logistic regression, and you be specific about it by calling this. It's going to be pulling its exact vectorizer, and you use the name steps function to pull from a pipeline. So whenever you have a specific step in a pipeline and you want to reference it, you do name steps. And then you pull out the feature names. So because it made every word into a unique column, it would you can get all those and extract those using get feature names out. And then you use the vectorizer to do that. The cofs would be the weights of each model. So when you would run through the model, it would obviously give every like unique value a number. And obviously the positive is so this is like an example. So like love might pop up more than usually, so it gets a score of 2.5. And then yeah, so this is how it would work. When you call this function named argsort, it basically sorts out the actual features itself, but then it returns the index. So we sort from like least to greatest, and it will tell you like which indexes are the highest and which indexes are the lowest. So what basically we're doing here is we're grabbing the most positive or the highest like weights itself and like which like items those are or which features those are. And then it's grabbing the most negative ones. So like the ones on the lowest of the list. So based off the weights, we're gonna categorize that and we're gonna plot it. So we're gonna create some bar graphs using the feature names as like the y-axis and then the coefs and actual like weights as the x-axis. So if we go down here, we can see that there's like more positive sentiments towards great and it has a higher coefficient than the other ones. And then there are less negative sense or there's more negative sentiments towards words like lame, like stupid, annoying, disappointing, and all these other different things. So it shows like a clear distinction between the two, and it shows that our models are actually working. So this is the last part that I'm going to be going over today. We can make real fast. So using the best model out of the pipeline, we can let's just choose like linear regression results and then logistic regression and then TF IDF and then pipeline. So to be specific to that pipeline, we're going to make a function for this. So we're going to clean the data, which we already created a function for it, and then we're going to pre-process text and then sample. So which is what our parameter is. And then prediction is equal to best model dot predict, which is the easy function that I talked about earlier, cleaned. And then we're gonna just pull the first one. Okay, cool. And then labels, I'm gonna label it as positive if prediction is equal to one, because if it's equal to one, that means it's the Boolean is true. Um, and then else negative. Okay, cool. And then we're gonna do a try here because sometimes they come back as empty, and if they come back as empty, then we need to make like an attribution error for that, which I will do right now. And then best model dot predict proba, which is just probabilities, but they want to be weird. And then cleaned, and then 0. And then the confidence score we're going to be getting from the max probability. And then we're going to be multiplying that by 100 because it comes as a decimal. And then we're going to be making a string for that, which we're going to be printing towards the end. So it's going to be this F and then con, uh, confidence. Then, putting our variable into there. And then we're going to be doing a except and then attribute error. And then we're just going to be, instead of, if this does happen, that means it's just empty. So we'll just return an empty string. And then we can write the reviews for it, or we can print the results, which We don't want to print the whole thing because they're very long, so we'll just do 120 characters and then label, which is what they predicted, and then the confidence like value. So this is just like some example reviews, and then we'll be running it through those. Um, yeah, see if this works. Which it doesn't. Name prediction is not defined. I probably just spelled it wrong. Yeah, let's try running that. There you go. It shows the review and then an absolute masterpiece. The performances are outstanding, which is obviously positive, and it gets positive, and it has that confidence on there. So, but the like interesting thing and the thing to keep out for on your own models is that it doesn't always get it right. So this last review, not bad at all. I went in with low expectations, but it ended up really enjoying it. It reads that as a negative, and the only reason it does that is because not bad. Bad is obviously like it counts a lot more. And if your engrams is not like grouping those correctly, then it's gonna like misread it. And you have to like keep watch for those errors. And you have to actually fine tune. So there's different techniques that you can do for that. So there's like a text, you can do more text pre-processing, which is like you can do stemming instead of lemmatizing, which is like a whole different process. You can add more stop words, keep certain stop words that you're noticing. So each method is specific to your own data set, and you that's why data like EDA and like knowing your data set in advance is really helpful for helping you actually use this prediction or and then like running these models as well. So you can do some vectorizer tweaks. So like the n-grams, if it was a trigrams like with three and it groups by three, then it might have had a better chance of catching this not bad. Um, you can do some other things like ignore certain words that appear too much, too little, try a new model entirely instead of doing logistic regression or any of the other ones. You can try any of these, or there's some more advanced models that you can do, or things that you can do as well by like doing these ones right here. But and then again, just to test it, his movie, his buns, great. It's negative, and it's not that confident because buns is not really that popular, I guess. But yeah, that is the workshop for today. So thank you guys for attending, and I hope you guys do the best on the Datathon tomorrow. So thank you guys.